Hello, in this video, we'll look at exponential functions. An exponential function is a function that involves a constant base and a variable exponent. This function is a non-algebraic function. In fact, exponential, logarithmic, and trigonometrical functions are referred to as transcendental functions. You will see in an exponential function, the base is what we really denoted by a. For example, if we look at f of x is a to the x, a is a positive real number. So the base a, okay, a is called the base. And that has to be a positive real number other than 1. So it's very important. The base cannot be 1 in an exponential function. And the exponent x can be any real number, okay? So if we look at the definition, which is written out in words here, but let's just take that from our textbook. So a summary, the exponential function f with a base a is denoted by f of x equals a to the x. Well, a has to be greater than 0. A cannot be 1, and x is any real number. So if we become familiar with some of these examples of exponential functions. So if we look at some examples of the way they're written, we can have f of x is equal to 2 to the x. Here, the base is 2, okay? So this is our first example. If we look at g of x is equal to 5 to the x. Here, the base is 5. Okay. If we look at the example, h of x is equal to 1/4 to the x. The base is 1/4. And one more example, if we have a of x is equal to 3x plus 1, here the base is 3. Now, to become familiar with exponential function, let's look at an example where we can evaluate it. Okay. So if we have f of x equals 2 to the power of x, which is exponential, we're going to evaluate when x is equal to 0, when x is equal to 1, when x is equal to 2, and x is equal to -3. Okay? So if we try this, we have f of x is equal to 2 to the x. So f of 0 will be 2 to the 0 power. And 2 to the 0 power, anything to the 0 power, that is equal to 1. So f of 0 is 1. So keep in mind, the point here, point x is 0, y is 1. Okay? Likewise, we can say when x is equal to, what is f when x is equal to 1? Okay, so f of 1 will be 2 raised to the power 1. Therefore, f of 1 is equal to 2. And if you want to write that as a point, that will be 1, 2. Okay. Likewise, when x, so this is when, here is when x is equal to 1, here when x is equal to 0. Now, what happens when x is equal to 2. So we have f of 2 will be the 2 raised to the second power. And that becomes f of 2 is equal to 4. So our point, if you want to write it as a point, is the point 2, 4. And then finally, we can look at when x is equal to minus 3. So f of minus 3 is going to be 2 raised to the minus 3 power. And keep in mind, for negative power, that becomes 1 over 2 to the positive third power, which is equal to 1 over 8. So if you write this as a point, x is minus 3 and y is 1/8. Okay. So as stated in the definition, okay, the variable exponent, okay, your variable exponent can be any number. Meaning that could be a positive or a negative number. Okay. So once we know how to evaluate any x, we are able to graph or see what the graph of an exponential function looks like. And that will be our next thing to master. So if you want to graph y equals 2 to the x, and you will notice that as you graph these functions, they all have something very similar. Okay, they're very similar in one aspect or two aspects when we look at the various graphs of them. So the first thing we can do by creating a table of random x values. So if we do this, we can draw a little table. And if this is x and that's y, and we can randomly choose x to be minus 3, minus 2, minus 1, 0, 1, 2, and 3. And if you plug those in, we did when it's minus 3 already, we saw that that will be 1/8. If you try minus 2, you will see you get 1/4. If you try minus 1, you will get 1/2. 0, we saw it's 1. When it's going to be 1, it's going to be 2. For 2, we did before was 8, and this, sorry, for 2, it was 4. And if you graph this, if you graph these points, you will now see that by looking at a xy axis, you will notice that first of all, the graph does pass through the point 0, 1. Okay. So by labeling the x and y axis with some values, okay, and I'm only putting some key points here. We know that this is when x is 0, y is 1. When x is 1, y is 2. When x is 2, it is 4. So 2, 3, 4. And that point is 4. We know when x is minus 1, it's a half, and so forth. So what you will notice is that the graph would look similar to this here. And this will be the function y equals 2 to the x. Okay. So some of the key points to note is here. Okay. Notice or note the graph. Okay. The graph does not cross the x-axis. Yeah. It approaches the x-axis, but never touches. And also notice that the graph, so let's say this is 1, this is 2, the graph has a y-intercept of 0, 1. So the y-intercept is 0, 1. Now, if you sketch various graphs, okay, if we sketch various graphs, of, let's say, y equals 2 to the x, y equals 3 to the x, and y equals 4 to the x, you will notice something that they all have a key point in common. So by creating a table of values, notice that I've shown here the graph of 2 to the x and 4 to the x. And if we actually had to fill in the graph 3 to the x, you will notice that 3 to the x will fall somewhere closer to 4 to the x. Okay, so that graph will be somewhere in here. Okay, this here would be the graph y equals 3 to the x. And they will all look like if they're falling on top of each other there, okay, because the graph is so small. So what do you notice? What you will observe is that the graph, okay, the graphs looks very similar. Okay, they're all increasing. They are all increasing. However, the graph of y equals 4 to the x is increasing more rapidly or faster, meaning that the graph is much steeper for positive x values, okay? More rapidly than the graph y equals 3 to the x, okay? So exponential function of these types are called growth functions, okay? So exponential functions of these types, so note exponential or increase exponential function called growth functions. Yeah, they're referred to as the growth function. Now, as we said, the exponent can be a negative, okay? So what happens if we also look, you will see that if we sketch the graph now of, let's say, y equals 2 to the minus x, okay, we will observe the following. Okay? You will see the following. Now, just as a quick reminder, so we have y is equal to 2 to the minus x, okay? And keep in mind that this is the same as y is equal to 1 over 2 to the positive x, okay? Or we can say that 1 over 2 everything to the x. Okay? So by creating a table of values, if we create a table of values, as we did before, and if we call this x and y, and we do -3, -2, -1, 0, 1, 2, and 3, okay? Now, when it's -3, this becomes this here, just to show you how I'm going to get this value. When x is equal to -3, we have y is equal to 2 to the minus, but a -3, okay? So we have y is equal to 2 to the positive 3, and therefore y is equal to 8. So this value here is 8. Okay, that means this value here will be 4. This value will be 2. And we know when it's 0, it's going to be 1. Okay. Now, when it's -1, it will be, when it's +1, it will be 1 over 2. And 2, it will be 1 over 4 and 1 over 8. Okay, because of the negative. Now, if we look at the graph of this, you will see that the graph looks very similar to what we've done before, but it is reflected over the y-axis. Okay. The graph will still pass through the point 0, 1. Yeah. And we know some key points here. 0, 1 will be there. Okay. We also saw that when it's -1, the value will be 2. And when it's -2, the value will be 4. And when it's -3, it will be 8, which I don't have points, space to plot all my points. And when it's 1, it's 1/2. So you'll notice now that your graph is now going this way. Okay. So the x-intercept is still 0, 1. We still have an x-intercept of 0, 1. And once again, the graph never touches the x-axis. And this here, this is an exponential decaying function. Okay? It's an exponential decaying function. As you travel from left to right, the graph moves downward. And that's the reason it's called a decaying function. Now, a similar process, if we now sketch the graph of, let's say, 1/2 x or 1/3 x and 1/4 x, okay? So if you look at the graph of 2 to the minus x, which is the same as 1/2 to the x power, or 4 to the minus x, which is the same as 1/4 to the x power, we will see the graph looks very similar but reflected to the two graphs we did before. So our graph looks very similar but reflected. Okay, so the graph appears to be similar. So they're all decaying function. Okay, they all share the same y-intercept. Okay, they all share the same y-intercept. Okay, so note the y-intercept is still 0, 1, and they are all called decaying function. Okay. They're called decaying because they decreases as you travel from left to right. Now, another type of exponential function is what we call natural exponential function. Okay, so not much difference, just that for a natural exponential function. So let's just write a little. Another type of exponential function is one when the base is e. And recall, e is approximately, okay, approximately 2.718 dot 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 2.7183 if you want 4 decimal places. Okay, and this function, okay, when the base is e, the function is called natural exponential function. So let's look at the natural exponential function now and see what does the graph looks like. Okay. So the natural exponential function, when the base of the exponential function is that special number e, okay, and we said keep in mind that e is approximately 2.7183 on and on and on. It's an irrational number because it never ends, no repeating decimals. Then it is referred to the natural exponential function. Now keep in mind e is a number and it's greater than 1, so this is an exponential function. Now e is just between 2 and 3, so the graph would look very similar to 2 to the x. So how do we evaluate these values? Well, let's try some example. So if you're given, let's say f of x is equal to e to the x, and you're asked to evaluate x equals 0, x equal 1, and x equal, let's say, minus 1. So when x is equal to 0, we have f of 0 is equal to e to the 0. Therefore, f of 0 is 1. E to the 0 is 1. So your point here is the point 0, 1, right? What happens when x is equal to 1? So we have f of 1 is e to the 1. So f of 1 is just e. So the point here will be 1 comma e. Okay? And when x is equal to minus 1, f of minus 1 will be e to the minus 1. Therefore, f of minus 1 will be 1 over e. So your point will be minus 1 comma 1 over e. And you can round these to decimals. There's nothing wrong with changing them to decimal, approximate decimals, okay? So if we now look at the graph, okay, let's graph y equals e to the x, okay? So the first thing we can do is create a table of values, okay? If we create a table of values, and if we have x and y equals e to the x, you will notice that if we have minus 2, then this becomes y equals e to the minus 2, which is equal to 1 over e to the 2. And as a decimal, this becomes approximately 0.135. Okay. If you try minus 1, you get y equal e to the minus 1, which is 1 over e, and that is approximately 0.368 to 3 decimal places. And you can continue doing this. You're going to have e to the 0, which is just 1. Okay. If we have a 1, you have y equal e to the 1, which is just approximately, I shouldn't say equal, approximately 2.72 if I round to 2 decimal places. Okay. If you try 3 now, so we have y equals e to the 3, and that is approximately 20.09. So if you graph these points, okay, if you plot the points, looks very similar to e to the x. Very similar. Well, one thing for sure is that the y-intercept is the same. Okay, 0, 1 will be a y-intercept. We have to be a little bit more careful because we're plotting decimal now. Okay, we're plotting decimals. So the first point I'm going to plot is the y-intercept 0, 1. And then we know when it's -1, it's approximately 0.3. So we'll really guess that out. And when it's 1, it's approximately 2.72. So that's just above a half. So you will see that your graph is looking very similar to e to the x. Very similar to 2 to the x power, sorry. So y equals e to the x. Now, it is still referred to a growth function, okay? So y equal e to the x is also a growth function. This is also a growth function, and the y-intercept is 0, 1. Yeah. So not much of a big difference between e to the x and 2 to the x. Okay. Now, if you're wondering, well, why are we learning about exponential function and logarithmic function, which we'll do next? Because these are very commonly used in our everyday life. And the reason I say that is because it's very commonly used in terms of money and interest in the bank. So I'll show an example, okay, of a common application problem. So one common application problem of natural logarithm or natural exponential for the natural exponential function is in business with interest-bearing accounts. And such formula is A is equal to P parentheses 1 plus R over N raised to the N times T power. So what does that really mean to you? So this gives the amount of money, A, okay, the amount of money that we call A in account if P dollars are deposited for T years, for some time T years, okay, at an annual interest rate or compounded n times per year. So A is the amount you receive after a certain time in the bank, okay? P is the amount of money you deposit into the bank, okay? R is the interest rate, okay? R is the interest rate. N is how many times you're compounded. So if the bank give rates semi-annually, meaning every 6 months, N will be 2. So let's look at an example, yeah? Because the example always gives you a good insight. Example. Yeah. So if you deposit $300 in an account, okay, with an annual interest rate of 8% compounded quarterly. Find the amount of money in the account after 5 years. How much money will we have in that account after 5 years? So let's write down what's given. Okay. Here is what we have. Okay. You deposit $300. Okay. You deposit $300. So P is equal to 300. Okay. The annual rate or, well, that's not, annual interest rate is 8%. Yeah. Your compounded quarterly, okay, and this means 4 times, okay, per year. So N is equal to 4, and T is equal to 5 years. Okay. So if we plug this into our formula, P is equal to A, okay, sorry, A is equal to P parentheses 1 plus R over N raised to the NT power. We have A is equal to 300, 1 plus R, 8%, and we should do this 8% is the same as 0.08, okay? So 0.08 over N, which is 4, and then N, which is 4 times 5, okay? So first thing we do is work on the inside of the parentheses. So A is equal to 300, 1 plus 0.02 raised to the 4 times 5 power. Right? 0.08 divided by 4 is 0.02. So A is equal to 300. 1 plus 0.02 will be 1.02. raised to the 20th power if we multiply. So a is equal to 300. You must do the exponent first. So this becomes approximately 1.4859. Therefore, a is, if you multiply those two numbers now, 300 times 1.4859. And since you're speaking of money, we'll round it to 2 decimal place. So we have 445.78. Okay, so note, when dealing with money or when working with money, we will round to 2 decimal places. Okay, 2 decimal place value. Now, keep in mind that you should find out what your regular interest rate is, right? The rate here was actually pretty high, 8%. Okay, so this is the way we'll work with financial problems or banking. We use the exponential function. Okay. So I don't want to make this video too long, so I'll break it up into 2 parts, right? So as always, you want to see if you can sketch graph of any other exponential function and practice more. And we'll continue with this in our next video.